Before 2015, scientists didn't know much about Pluto, the barren world. Because before that, not many missions had gone near Pluto, and Pluto was so far away that taking clear photos from a distance wasn't possible. Due to this, the best and clearest photo we had of Pluto was what you're seeing on the screen now. Hubble also turned its lens towards Pluto, but it was so small and distant that the best thing it could see was some color variations. But then everything changed in 2015. The New Horizons spacecraft reached Pluto after a long journey of 9 years. This space exploration was sent there to get good photos of Pluto and to learn about its conditions. But what it showed when it got there astonished the entire scientific community. Scientists couldn't believe their eyes. So what did New Horizons see during its journey to Pluto? What was Pluto's system like? My name is Adam, and you're watching Cosmic Discovery YouTube channel. Today, I'm going to take you on a tour of Pluto's world. Stay with me until the end of this video. Pluto was first discovered in 1930 by astronomer Clyde W. Tombaugh, observed it during his research at Lowell Observatory in Arizona, USA. At that time, the International Astronomical Union officially recognized it as the 9th planet in our solar system. For 76 years, Pluto maintained its status as a planet until its reclassification. The story of how it got its name adds another layer of intrigue. When it came time to name a newly discovered celestial body, suggestions were sought from the public. 11-year-old Oxford student Venetia Burney suggested the name Pluto, inspired by the Roman god of darkness. He argued that since this planet is shrouded in darkness in the outer reaches of our solar system, it seemed appropriate to honor a god of the underworld. Scientists agreed, and Pluto was created. Let's learn some interesting facts about Pluto. Pluto is an extremely picturesque but miniature world, much smaller than our moon. It resides within the Kuiper Belt, a vast region filled with asteroid-like objects and comets located beyond the orbit of Neptune. Its location at such a great distance from Earth, as well as its relatively unremarkable characteristics, contributed to Pluto being the last of the traditional 9 planets to be discovered. However, despite the initial lack of astronomical fascination, the diligent efforts of a dedicated team eventually led to the New Horizons mission being approved in 2006, marking a significant milestone in space exploration. The primary objective of the New Horizons mission was to reach Pluto quickly, making it the fastest spacecraft launch ever. Using the most powerful rocket available at the time, the fully upgraded Atlas V, New Horizons crossed the Moon in just 9 hours, 10 times longer than the Apollo missions took. On its way to Pluto, it strategically used Jupiter's gravity to catapult itself, shaving 3 years off its journey. This maneuver also served as a test bed for the New Horizons system, capturing breathtaking images and video of Jupiter and its moons along the way. Following its successful trial, New Horizons entered hibernation mode to preserve its instruments from wear and tear. As the 2015 approach drew near, the team reactivated the systems, eagerly awaiting the spacecraft's daily transmission of images from the Pluto system. This period was filled with anticipation for enthusiasts, offering glimpses of what Pluto might reveal and highlighting its distinct differences from its largest moon, Charon. With each passing day, the resolution of the images improved, revealing more intricate details. While the mission had various scientific objectives, the focus for many was on uncovering the visual aspects of Pluto. Soon, observers caught sight of what appeared to be a heart-shaped feature on the dwarf planet. On July 14th, the New Horizons probe executed its closest approach, coming within a mere 12,500 kilometers of Pluto's surface. However, mission controllers didn't immediately receive images due to the probe's extensive photography during the flyby and the subsequent slow data transfer rate of just 1 kilobit/SEC. Moreover, there was a 4.5-hour delay in communication between the spacecraft and Earth. Nevertheless, when the images finally arrived, they were nothing short of spectacular, showcasing mountain ranges, icy plains, glaciers, and even an atmosphere. Additionally, New Horizons provided valuable insights into some of Pluto's moons. Let's delve into the fascinating discoveries made during this flyby. One of the most intriguing findings concerns Pluto's unique relationship with its moons. Firstly, Pluto's largest moon, Charon, orbits remarkably close to Pluto and is proportionally quite large. This arrangement causes the barycenter, or center of mass, of the two bodies to lie outside of Pluto itself, resulting in both objects orbiting around a point in space. Furthermore, both Pluto and Charon are tidally locked to each other, meaning that one always faces the other, much like the Moon does with Earth. This mutual locking is rare in celestial bodies, as typically only moons are tidally locked to their parent planets, not vice versa. Charon stands out visually from Pluto due to its notably darker appearance, hinting at potential differences in their origins. Additionally, Pluto's other moons are relatively small, measuring only a few kilometers across. Interestingly, their orbits exhibit exceptional circularity and align closely with the plane of Pluto's orbit around the Sun. These characteristics add to the complexity of Pluto's moon system and raise intriguing questions about their formation and evolution. The geology of Pluto is absolutely captivating. The extraordinary feature that has captured the world's imagination is the giant heart-shaped area known as Sputnik Planitia. It is the size of Texas, and its color contrasts sharply with the surrounding area. This is because it is a huge ice field. Sputnik Planitia is essentially a giant ice field, with 98% of Pluto's surface composed of nitrogen ice. Despite the average surface temperature of -229 degrees Celsius, nitrogen ice behaves remarkably like water ice on Earth, causing it to flow like glaciers. On the contrary, nitrogen ice behaves similarly to water ice on Earth at these temperatures, allowing it to flow like glaciers. This phenomenon is particularly evident around the perimeter of the heart-shaped region, where glaciers cascade into the crevices around craters and mountain ranges. Additionally, the ice plains exhibit expansive polygonal shapes across their entirety. The absence of craters suggests that this feature is either relatively recent or constantly undergoing renewal processes, potentially making it only around 10 million years old. Moreover, the polygonal cells display ridges, likely formed by sublimation, where ice transitions directly into gas. Regular sublimation and freezing of ices occur here, forming troughs and pits, indicating that these polygons likely represent convection cells. These cells are in motion and can be observed flowing into the surrounding mountain ranges via slow-moving glaciers. Sputnik Planitia bears resemblance to Greenland and Antarctica in that it significantly influences Pluto's climate. While not confirmed, Sputnik Planitia may have originated from an impact event, with ices filling the resulting crater from a potential subsurface liquid ocean. This filled-in basin creates a positive gravitational anomaly, where gravity at one point differs from elsewhere on the object. The ice plane directly faces away from Charon, aligning it with the object's tidal axis. Given the close proximity between Pluto and Charon, tidal effects exert significant influence on both objects. This tidal interaction could explain why Pluto is tidally locked to Charon, preventing either object from turning away from the other. Surrounding the expansive ice plains are immense mountain ranges composed of water ice, which present a spectacular sight when viewed from the side. Water ice is the sole type of ice identified on Pluto that possesses the strength to uphold heights of several kilometers at such frigid temperatures. Among Pluto's array of mountains, some may potentially be cryovolcanoes, with Right Mons emerging as one of the primary contenders. Standing at a towering 4 kilometers, Right Mons ranks among the loftiest peaks on Pluto, featuring a significant depression at its center. Cryovolcanoes could play a role in maintaining Pluto's youthful surface. Another captivating region is Tartarus Dorsa, characterized by an extensive and distinct set of mountains towering 500 meters high, resembling the texture of snakeskin or tree bark. These formations are believed to be penitentes, making Pluto the only known location in our solar system, aside from Earth, where they have been observed. Penitentes are exceedingly rare even on Earth, with some occurrences found in the Atacama Desert and other arid high-altitude regions. However, those on Pluto surpass their earthly counterparts in both height and coverage area. The intricacies of these formations remain a source of fascination, leaving much to the imagination until observed up close. Another prominent characteristic of Pluto is the presence of dark material scattered across its surface in certain regions. The largest such area is known as Cthulhu Macula, which intriguingly bears a resemblance to the shape of a whale, as depicted in this image. Unlike the heart-shaped feature, Cthulhu Macula exhibits a significantly higher density of craters, indicating its comparatively older surface. Amidst Cthulhu Macula, mountain ranges are visible, crowned with what is believed to be methane ices. Methane tends to condense as frost at elevated altitudes on Pluto. The dark hue is attributed to the deposition of tholins, a type of tar-like substance composed of hydrocarbons that have undergone interaction with sunlight. Similar deposits have been observed on one of Saturn's moons, Iapetus, suggesting a recurring process within the solar system. Upon the initial transmission of images by New Horizons, scientists immediately suspected the presence of tholins on Pluto's surface. However, the selective distribution of this substance puzzled researchers. Why are only specific areas covered, and what are the dynamics governing the dispersion of tholins? Is Pluto's appearance relatively stable over time, or does it represent a continually evolving environment? These questions remain at the forefront of ongoing investigations into Pluto's surface composition and geological processes. It appears that these tholins could be closely linked to the cryovolcanism observed on Pluto. Pluto stands out as one of the rare celestial bodies in our solar system where cryovolcanoes actively contribute to shaping its surface. These cryovolcanoes eject water from either the mantle or trapped pockets within the crust, resulting in the formation of diverse terrain. However, it's not just water that emerges from these eruptions. Tholins are evidently present in the mix as well. Observations from the Hubble Space Telescope indicated a reddening trend on Pluto, with New Horizons potentially encountering the dwarf planet during its peak red phase of the year. New Horizons might have uncovered the reason behind this phenomenon. In an area known as Viking Terror, we can observe a cryovolcano that spewed forth a mixture of water and tholin across its immediate vicinity. Adjacent to this region, we can see evidence of another eruption, with a crater and trough filled by the same slurry. Along the trough, traces of the slurry's flow path and pooling can be discerned. This phenomenon is also evident in another area near Virgil Fossae, where a trough serves as a pathway for this slurry's descent. However, the most intriguing aspect regarding tholins is not observed directly on Pluto, but rather on its companion dwarf planet, Charon. Upon examining this enhanced color image of Charon, what immediately catches your attention? It's the red cap adorning its north pole. Remarkably, due to Pluto's weak gravity, when it ejects this slurry mixture, some of it escapes Pluto's gravitational pull altogether and embarks on a 19,000 kilometers journey to reach Charon. The concentration of tholins on Charon is significant because Pluto and Charon are tidally locked to each other, meaning they always present the same face to one another. Figuratively speaking, Pluto perpetually conceals its heart from Charon in this eternal dance. Consequently, more tholins accumulate in specific areas on Charon, rather than being distributed evenly across its surface. And speaking of Charon, several intriguing discoveries have been made about it as well. It's a world of water ice, in stark contrast to Pluto, whose surface is mainly composed of nitrogen ice. Consequently, it lacks a substantial atmosphere like Pluto's, as the water ice remains bound to the surface. On Pluto, the atmospheric dynamics are influenced by the sublimation and refreezing of nitrogen ice, leading to significant variations in atmospheric density throughout its 248-year-long seasonal cycle. This cyclic process of sublimation and refreezing can cause dramatic changes in Pluto's appearance over time. For me, one of the most astonishing confirmations by New Horizons was the presence of an atmosphere on Pluto. And not only that, but the images captured were truly breathtaking. Because of Pluto's diminutive size and feeble gravitational pull, its atmosphere appears to extend far above its surface. In contrast, Earth's atmosphere, although significantly denser and more massive than Pluto's, adheres closely to the planet due to its much stronger gravity. On Pluto, the atmospheric pressure is extraordinarily low, measuring roughly 10 microbars, which is 100,000 to 1 million times weaker than Earth's surface pressure. There's a hypothesis suggesting that this pressure could surge to between 18 and 280 millibars, approximately 3 times the surface pressure on Mars and a quarter of Earth's surface pressure. Throughout Pluto's orbital year, there are instances when it moves closer to the Sun than Neptune. During these periods, temperatures rise, causing surface ices to sublimate into gases, a process evidenced by observations of the ice plains. However, the last time Pluto is believed to have had an atmospheric density akin to Mars was approximately 900,000 years ago. Under such pressure and temperature conditions, it's plausible for liquid nitrogen to form on Pluto's surface, possibly indicated by what seems to be a frozen lake. Over the span of just 1 year, Pluto's atmospheric density can fluctuate significantly due to seasonal variations, sometimes by a factor of 4. This fluctuation stands in stark contrast to other solar system objects with atmospheres, which tend to maintain more consistent densities. The composition of Pluto's atmosphere includes the same ices found condensed on its surface, namely nitrogen, methane, and carbon monoxide. Another captivating revelation from New Horizons regarding the atmosphere is the presence of up to 20 haze layers. While the existence of haze layers was anticipated, the sheer number of them was surprising. These layers are clearly visible in certain images, resembling thin layers of fog. In one such photo, sunlight penetrates through a haze layer, casting shadows of the mountains against the backdrop of the illuminated haze. Interestingly, the layers do not seem uniformly distributed across the planet. In some areas, they appear to hover high above the surface, while in others, they come into contact with it. As a side note, I find these Pluto images to be the most awe-inspiring, and I intentionally saved them for last. They offer a profound sense of depth and scale, particularly in the portrayal of the mountain ranges. Despite Pluto's diminutive size, its extreme topographical relief makes it appear almost like a miniature model. The towering mountains owe their imposing stature to Pluto's limited gravitational pull, which lacks the strength to diminish their height. In June 2020, researchers published a paper proposing the existence of a subsurface ocean of liquid water beneath Pluto's icy exterior, akin to the oceans found beneath the surfaces of moons orbiting gas giants. Initially, it was assumed that Pluto formed under cold conditions, given its considerable distance from the Sun. However, insights gathered from New Horizons suggest otherwise, indicating that Pluto likely began its existence in a state of warmth. This implies the presence of a long-standing ocean beneath its surface, raising the intriguing possibility of habitability on Pluto comparable to that of its closer icy moon counterparts. Moreover, if Pluto serves as a model for dwarf planets within the Kuiper Belt, it suggests the potential existence of numerous habitable worlds in this region of the solar system. What evidence supports the idea of a warm start for Pluto? Observations reveal surface features indicative of expansion rather than contraction, manifested in cracks that suggest the crust is undergoing spreading rather than folding. If Pluto did indeed experience a warm start, possibly fueled by early bombardments from other celestial bodies during the formative stages of the solar system, it may have harbored an ocean shortly after its formation due to sufficient thermal energy. This perspective significantly alters our understanding of solar system formation dynamics. Although the complete absence of craters is primarily observed in Sputnik Planitia, it's striking how few craters exist on Pluto and Charon overall. This scarcity might not solely be attributed to the youthfulness of their surfaces, but could also hint at the Kuiper Belt containing fewer smaller objects than previously assumed. Following the brief flyby, New Horizons embarked on a journey deep into the Kuiper Belt. By this point, the spacecraft had traversed such a vast distance from Earth that its perspective of our nearest star system, Alpha Centauri, differed noticeably from ours due to the parallax effect. I've covered this phenomenon in another video if you're interested in exploring more astronomical examples. Contemplating the immense distance traveled by New Horizons relative to us is truly mind-boggling. It's astonishing to consider that Alpha Centauri has shifted from New Horizons' viewpoint, highlighting the spacecraft's remarkable journey. Conversely, despite New Horizons' extensive travels, its impact on our perspective of our closest celestial neighbor remains minimal. Such reflections underscore the sheer vastness of space. Thanks for watching. If you enjoyed this New Horizons video, be sure to subscribe to the channel.